Once hypotheses are set up, it is easy to detect whether the test is one-tailed or two-tailed. One-tailed alternatives are phrased in terms of less than or more than. Two-tailed alternatives are phrased in terms of not equal to. So in the case of the pizza one, it should be one-tailed. Pizza manager's alternative hypothesis is one-tailed because he's trying to prove that the new style pizza is better than the old style pizza. Types of errors. Regardless of whether the manager decides to accept or reject the null hypothesis, it might be the wrong decision. He might incorrectly reject the null hypothesis when it is true, or he might incorrectly accept the null hypothesis when it is false. These are respectively called type 1 and type 2 errors. A type 1 error occurs when you incorrectly reject a null hypothesis that is true. A type 2 error occurs when you incorrectly accept a null hypothesis that is false. The traditional hypothesis testing procedure favors caution in terms of rejecting the null hypothesis. Given this rather conservative way of thinking, you are inclined to accept the null hypothesis unless the sample evidence provides strong support for the alternative hypothesis. If you reject H0 and H0 is true, it's a type 1 error. If you do not reject H0, and HA is true, then it's a type 2 error. Significance level and rejection region. To decide how strong the evidence in favor of the alternative hypothesis must be to reject the null hypothesis, one approach is to prescribe the probability of a type 1 error that you are willing to tolerate. Type 1 error. So you reject the null hypothesis even though the null hypothesis is true. The significance of the rejection region is the set of sample data that leads to the rejection of the null hypothesis. The significance level alpha determines the size of the rejection region. Sample results in the rejection region are called statistically significant at the alpha level. It is important to understand the effect of varying alpha. If alpha is small, such as 0.01, the probability of a type 1 error is small, and a lot of sample evidence in favor of the alternative hypothesis is required before the null hypothesis can be rejected. When alpha is larger, the rejection region is larger. Avoid the use of a significance level and instead simply report how significant the sample evidence is. This approach is currently more popular. It is done by means of a p-value. The p-value is the probability of seeing a random sample at least as extreme as the observed sample. So given that the null hypothesis is true, the p-value. So this is what we were doing in my statistics class like 2 years ago or 3 years ago. That's funny. The probability of seeing a random sample at least as extreme as the observed sample, given that the null hypothesis is true. The smaller the p-value, the more evidence there is in favor of the alternative hypothesis. Sample evidence is statistically significant at the A level, alpha level, only if the p-value is less than alpha. The advantage of the p-value approach is that you don't have to choose a significance value, alpha, ahead of time, and p-values are included in virtually all statistical software output. Type 2 errors and power. Type 2 error occurs when the alternative hypothesis is true, but there isn't enough evidence in the sample to reject the null hypothesis. This type of error is traditionally considered less important than a type 2 error, but it can lead to serious consequences in real situations. The power of a test is 1 minus the probability of a type 2 error. It is the probability of rejecting the null hypothesis when the alternative hypothesis is true. There are several ways to achieve high power, the most obvious of which is to increase sample size. Increasing sample size? I hate this. This bullet point applies to this. The probability of a type 2 error is this bullet point. The probability of rejecting the null hypothesis when the alternative hypothesis is true. And the power of a test is 1 minus this. So basically, if you have the opposite, the power of when using a confidence interval to perform a two-tailed hypothesis test, rejects the null hypothesis if and only if the hypothesized value does not lie inside a confidence interval for the parameter. Practical versus statistical significance. Statistically significant results are those that produce sufficiently small p-values. In other words, statistically significant results are those that provide strong evidence in support of the alternative hypothesis. Such results are not necessarily significant in terms of importance. They might be significant only in the statistical sense. There is always a possibility of statistical significance, but not practical significance with large sample sizes. By contrast, with small samples, results may not be statistically significant, even if they would be of practical significance. Hypothesis tests for a population mean. I feel like the charging is being slower and slower every single day. The key to the analysis is hypothesis test for a population mean. As with confidence intervals, the key to the analysis is the sampling distribution of the sample mean. If you subtract the true mean from the sample mean and divide the difference by the standard error, the result has a t-distribution with n-1 degrees of freedom. In a hypothesis testing context, the true mean to use is the null hypothesis value, specifically the borderline value between the null and alternative hypotheses. This value is usually labeled the thesis. To run the test, referred to as the t-test for a population mean, you calculate the test statistic as shown below. T-value equals the sample mean minus the pop something. The ratings for the 40 randomly selected customers are shown on the next slide. To run the test, calculate the test statistics shown in cell E9 using the borderline null hypothesis value 0 and report how much probability is beyond it. In the right tail of the appropriate t-distribution, the right tail is appropriate because the alternative is one-tailed of the greater than variety. T-value indicates the sample mean is slightly more than 2.8 standard errors to the right of the null value, which provides a lot of evidence in favor of the alternative. If the alternative is still one-tailed but of the less than variety, the analysis remains virtually unchanged. And they calculated a p-value of 0.004, which basically means that it's good. That was funny. Two-tailed test. Oh, this is so long. The PowerPoint itself is so long too. But there's no way I'm still gonna get through the PowerPoint way more quickly than if I was to read the whole textbook or the whole chapter in the textbook like I usually do. I'm gonna run out of time. How much time am I going to even be able to have to study for my test tomorrow? Thank goodness I actually went to that extra class session that we had yesterday to review for the test because I'm going to have barely any time to study for this test unless I want to turn this assignment in late because I can't just do this assignment tomorrow because I have another test to do tomorrow other than the intermediate accounting test. It's a take-home test for my other class, and he made it due Friday for no apparent reason. Why'd you make it due Friday? You could have given us the whole weekend to do the assignment, but instead you had to make us do it on Friday. And then what are we supposed to do all weekend? I guess study for the actual test because that's not even the whole test. Just as we developed confidence intervals for a variety of parameters, we develop a hypothesis test for other parameters. In each case, the sample data are used to calculate a test statistic that has a well-known sampling distribution. Then a corresponding p-value measures the support for the alternative hypothesis. Hypothesis tests for a population proportion. To test a population proportion p, recall that the sample proportion has a sampling distribution that is approximately normal when the sample size is reasonably large. The distribution of the standardized value p hat minus p over the square root of p times 1 minus p divided by n is approximately normal, with mean 0 and standard deviation 1. This leads to the following z-test for population proportion. Let p0 be the borderline value of p between the null and alternative hypothesis. Then p0 is substituted for p to obtain the statistic below. Example: customer complaints at Walpole Appliance Company. Use a test for proportion to see whether a new process of responding to complaint letters results in an acceptably low proportion of unsatisfied customers. Solution: the manager's goal is to reduce the proportion of unsatisfied customers after 30 days from 0.15 to 0.075 or less. With the new process in place, the manager has tracked 400 letter writers and found that 23 of them are unsatisfied. After 30 days. That is a weird way to measure it, because you're not going to write a letter unless you're unsatisfied. Why would you write a letter to be like, yeah, this was a great appliance you installed. Thank you so much. Nobody writes the letter for that reason. Tracked and found that 23 of them are unsatisfied after 30 days. One-tailed, less than. We want it to be less. Hypothesized proportion 0.075. Sample size number. So the proportion is 0.058, and the standard error is this, and the test statistic is this. Z-value negative 1.329. Wait, why is it so simple? The p-value. Oh! Where did they get all that information, dude? If B2 equals... Why would they do that? That's such crap. That is such crap. What? Why are you doing that? Why wouldn't you just type the formula for it's less than, because we already know it's less, we want it to be less than. Wait. That is so complicated. They got a p-value of 0.09. Hypothesis tests for differences between population means. Man, it's going to be sad if I can't do this assignment today. Oh my gosh. Like, there's going to be so many problems. I somehow doubt I'm going to be able to finish them all today. Dude, I might have to turn this in 2 days late. 2 days late. Just great. The comparison problem where the difference, hypothesis test for differences between population means. The comparison problem where the difference between two population means is tested is one of the most important problems. The form of analysis depends on whether the two samples are independent or paired. If they are paired, then the test is referred to as the t-test. For difference between means from paired samples, if the samples are independent, test is referred to as the difference between means from independent samples. Use paired sample t-tests for differences between means to see that was funny. To use p-test of a paired sample t-test for differences between means to see whether consumers rate the attractiveness and their likelihood to purchase higher for a new style can than for the traditional style can. Oh. Randomly selected customers are asked to rate each of the following on a scale of 1 to 7. Maybe I'm just going to skip all this stuff because I'm trying to just do the quiz here. Measuring the effects of soft drink cans. That was funny. Okay. You know what? I'm skipping all this stuff. So maybe this PowerPoint might have some extra information on how to do problems if I ever need it. So like if for one of the future assignments, she doesn't post the video in time, then I will check the text, and if the textbook is being stupid, then I can check the PowerPoint. And also I can also check the additional resources provided, because those might hypothesis test for equal population variances. F distribution Dang. I'm not going to look at the examples. I'm just going to read the concepts. Test for normality. Many statistical procedures are based on the assumption that population data are normally distributed. The tests that allow you to test this assumption are called tests for normality. The first test is called Chi-square goodness of fit test. A histogram of the sample data is compared to the expected bell-shaped histogram that would be observed if the data were normally distributed with the same mean and standard deviation as in the sample if the two histograms are sufficiently similar to the one. Hypothesis of normality is accepted if the goodness of fit measure in the equation. Oh, normal. They're like, close enough. I mean, really? You think this is good enough? Dude, it literally has a p-value. Wait. The null hypothesis is that it's normal. So p, that means as long as p is a decent amount, that means it's the opposite of the other one. 52%. Lilliefors test. Ooh. That is pretty close when you look at it like that. What? Ooh. Quantile plot. Oops. You messed up. Why is this? Why are this chi-square tests for independence? Oh my gosh. Hmm. Dude, I have to take 4 tests in like the next 4 days. Well, no. Like, I have to take 2 tests on Friday, 1 test on Monday, and 1 test on Tuesday. And 2 of the tests I just described are for the same class. It's just that it's 1 test divided into 2 parts. Okay. Feel like so that was way faster than reading the chapter. Oh my goodness. But let's see how well that I do here. Null hypothesis is the hypothesis that represents the current thinking or status quo. Alternative hypothesis is the hypothesis that the analyst is trying to prove or research hypothesis. One-tailed test. The test where values in only one direction will lead to rejection of the null hypothesis. Two-tailed test where values in both directions will lead to rejection of the null hypothesis. Type 1 error is error committed when null hypothesis is true but is rejected. Type 2 error is when the null hypothesis is false but is not rejected. Significance level is the probability of a type 1 error an analyst chooses. Rejection region is the sample results that lead to rejection of null hypothesis. Statistically significant results, sample results that lead to rejection of null hypothesis. P-value p-value. The probability of observing a p-value is the probability of observing a sample result at least as extreme as the one actually observed. Power is the probability of correctly rejecting the null when it is false. T-test for a population mean. Test from a mean from a single population. Man, I want these templates. I want these templates, dude. Why can't we have those? I need those templates. Z-test for a population proportion. Z-test for a population proportion. Test for a proportion from a single population. T-test for difference between means from pairs samples. T-test for difference between means from independent samples. F-test for equality of two variances. F distribution is a skewed distribution useful for testing equality of variances. Z-test for difference between proportions. Tests for normality. Test what to check whether a population is normally distributed. You could use the chi-square test, the Lilliefors test, and QQ plot. The chi-square test for independence. Checks to check whether two attributes are probabilistically independent. So, are we going to fail? Last two quizzes, I got 18 out of 20. I've missed one question for the last two quizzes, which is very sad. Oh, man. So, let's just hope I don't fail. I've read the PowerPoint, and I even reviewed the key terms, and I can even look back at this stuff while I'm taking the quiz. So, oh, great. Oh, great. Oh, great. Oh, great. Oh, great. Oh. I think it's like less than 0.05. Oh, dude. Okay, I'm going to go back to that one because I thought it was like less than 0.05. I feel like less than... I mean, if it's any less than 0.05. Power... Probability of correctly rejecting the null when it is false. Reject the null when... So rejects the null when the null is false. Rejects the null when the alternative hypothesis is true. The hypothesis that an analyst is trying to prove is called an alternative hypothesis. Which is more serious? Type 1, I think. Type 1. Type 1 is... the chi-square goodness of fit test. Oh. Chi-square. Okay. Tests for normality. Chi-square goodness of fit test is a test for normality. An informal test that utilizes a scatter plot and looks for clustering is known as a QQ plot. Quantile plot. Where is it? I forgot where it is. Quantile. A type 2 error is when null hypothesis is false but is not rejected. The null hypothesis is incorrectly accepted when it is false. Smaller p-values indicate more evidence in support of the alternative hypothesis. The p-value of a sample is the probability of seeing a sample result at least as extreme as the one actually observed. The probability of seeing a sample with at least as much evidence in favor of the null hypothesis as the sample actually observed. I'm just going to let this up. Man, I hate this. Chi-square test for independence. Dang it! I'm having trouble. Oh my gosh. The probability of seeing a sample with at least as much evidence in favor of the alternative hypothesis as the sample actually observed, given that the null hypothesis is true. I was confused. At least as much evidence in favor of the alternative. Okay, so we got 9. I think there's only a couple I'm missing here. We just need 1 and 10. So we need like the convincing level of that. What's the convincing one? I mean level. I hate everything. According to this, so a convincing level one is 0.01. That's what they want. And then one more question. Chi-square test for independence. I'll read the textbook explanation of it because I don't know if I can really get it from the PowerPoint. Compare the actual accounts and the contingency table with what would be expected under independence. Compare the cumulative distribution with what would be expected. Okay, hold on. I think it's the contingency table one. That was funny. Stop. I don't even want to study for a test, and I don't want to do the other assignment. And I don't want to do all the problems. I don't want to. Oh my gosh. Oh my goodness. Dude, I don't want to take a test tomorrow. Okay. Please. Just please. Okay. That was fine. I don't want to do the assignment. I don't want to do anything else. My grade barely went up. Dude, I don't want to do... I might just save the entire assignment for Saturday because I just... Like, what are the chances that I can get the whole thing done today? What are the chances? I mean, I could. That was funny. I could have done it, but I just need to study for my test. Where did I mess up in the problems yesterday? I need to look at the... Maybe if I look at the solutions. Okay, so what I'm going to do is look at... my solutions for the practice problems and see what I messed up, because I did the entire thing by myself and then I got a couple things wrong when he showed the solutions. So what did I get wrong here? So first of all, capitalization of interest. So in this problem, I did something wrong. So for calculating avoidable interest, you don't need to multiply it by 0.5833. To calculate avoidable interest, just do the thing. Oh my gosh, I don't want. No, I don't want to do this. Dude, am I gonna have to do this whole problem again? Dude, like, this is so complicated. What I did wrong initially was I multiplied it by 0.5833 because I thought it was that, since it was only part of a year, that's what you do. But in fact, you don't do that for avoidable interest, but you would do in fact do that for the actual interest. For the actual interest, you do have to multiply it by the partial year. But for the avoidable interest, you don't, apparently. Like, apparently you don't. So that's the reason I messed that one up. But I did everything else right. And then here, I did mess up something. So on this question, what did I mess up? What I messed up was the fact that you have to include the insurance in here. Why would you include that? Why would you include that? Why would you include the insurance cost in the cost of the buildings? Why would you do that? 3 out of 36 months? Fire insurance premium payment is required for in the cost of the building. It's required. Fire insurance premium. And they're only going to pay the fire insurance for 36 months. Three-year term. You include the fire insurance premium in the cost. Land. So that's the only mistake I made in this problem, is the fact that I was supposed to include the fire insurance. So they paid $5,400. That's the entire thing, but you only include 3 out of 36 of it, $450. So that's the only thing I messed up in that question. Now, what about here? I believe I got this right. I got this one right. Impairment. I did something wrong because I was a stupid idiot. I was just a stupid moronic idiot. It's not this number divided by 4, you stupid idiot. Wait, hold on a second. Yeah, so basically the reason I was a stupid idiot is because I forgot to reduce the carrying amount by this amount for some reason. Like, I was stupid, it's stupid. So get your new, this minus this equals the new value, and then divide by 4 equals this correct amount. Stupid idiot. So depletion. I got the right answer for depletion, but it's going to be more complicated because, so I only got like 2 minor things wrong when we were doing our practice session. So, but the problem is I looked at the textbook while doing the problems. So what if I forget the things, how to do the problems? Oh, I don't want to take this test. Oh no. Oh my goodness. I don't want to study for this test, and I don't want to take this test. So yeah, I was able to do this one entirely correctly, but the problem is there's going to be a stupid, idiotic timber question, which I was so confused by in the class. So I think what I need to do, okay, first of all, the capitalization of interest one is like so incredibly complicated that I might forget how to do it. Okay, so you take this number, you do this number, subtract 1.7 million to get this. Wait, seriously? No, this number minus 1.7 million to get this number, and then this number is this number. Do not do this. You do this times this times this to get avoidable interest, and then the actual interest, you do this times this and this times this, but you also do this because it's only part of a year, and that's the interest, and then compare these two numbers. Yeah, I mean, it's not that complicated, is it? My goodness, I'm going to mess something up. Okay, I need to look at, there better be a timber-related question in our previous assessment. Well, it's fine if it's not, because if there isn't, then I can just look at the in-class problem. Just out of curiosity, I just want to see. That was funny. This thing here. Because that's what we were doing yesterday in the extra review session. Wow. Very cool. What? Wait, so he has the problems and then he has the solutions down here. So 1.7 times the interest rate. And then the 466,667, he didn't include the calculation for this number, but it's this number minus 1.7 million to get this. So, and then you get this times this, and this times this, and then you get avoidable interest, actual interest incurred, this times 7 over 12, and then this times this, and then add in this. This is the lesser of this and this. So the interest can be capitalized is this, which is the lesser of the avoidable interest and the actual interest. Capitalizing acquisition costs, land and old building. So land and old building, removal of old building. Hey, look at that. Look at that. Legal fees, special assessment is included. Yeah, the only reason I got that right is because I looked it up in the textbook. Like, what if I'm not able to remember specific details of, like, what's included and what isn't included? Oh. Balance. So, buildings, we have legal fees, partial payment, insurance. Insurance, the fire insurance? Really? That's included? Final payment, superintendent's salary, balance, depreciation solution. That was very easy. I'm very good at the depreciation. I can kill myself. Oh, whoopsies. Oh, jeez. Wait. What? Wait. Oh, stupid. So, double declining balance. It doesn't look like he included the solution for double declining balance. Wait. Oh, he did both this and this. Okay. Oh. Impairment. Right. Yes. Impairment. The impairment one is actually pretty dang easy in terms of math. It's just the concepts you have to remember. Impairment entry is loss on impairment, accumulated depreciation. Make sure to differentiate how to calculate impairments. See if you can determine the fair value of the asset based on the market price, if it exists. If no market price exists, use the undiscounted present value of expected net cash flows. I might spend a bit of time like tomorrow morning studying, maybe 15, 20 minutes. Should I get up early? That means I'd have to get up early. Gotta be kidding me. Like, I'd have to get up early tomorrow. Well, not really, because I could technically get to school. I don't have to get to school 30 minutes early. Maybe I should... Like, I wish I could get into the classroom early so I could go on a computer and study it a little bit before. But maybe instead of that, I should just print some stuff. No, I can't print. I literally can't print anything off because I don't have a printer. But I should just put a few things on my phone so I can study my phone for a little bit while I'm in the car before the test, because that was funny. Depreciation expense, accumulated depreciation, depletion. Just divide by this. This plus minus this plus this divided by this equals this. This times this equals this. That's it. Wow, it's weird. He did all solutions in a Word document. Okay. And one, I was going to look at the timber problem because he specifically mentioned it. And I'm so confused by the timber problem. That was fun. And also, what if the timber problem is not in the assessment? I am so confused by timberland because it literally regrows back. The stinking thing regrows. How are you supposed to deal with that? Did it even explain how to deal with that in the book? How to deal with the timberland? Where basically if you deplete these resources, some of the resources will grow back. Are you kidding me? Are you kidding me? Also, I got this one partially wrong. Let's see. No freaking way. Look at this. That's the one question I got wrong in the assessment. That was a funny use of the word freaking. Bye.